Hi, this session is on regression analysis. In our last lecture, we have discussed about correlation, right? Now, before getting into the actual calculation of regression or performing regression analysis, let us try to understand the difference between correlation and regression. Now, see, correlation is also for bivariate data. Regression is also fundamentally for bivariate data if we talk about simple regression. Correlation tries to study the relationship between two variables under study, and correlation results in three different things. That is, it tells us whether variable x and variable y are related to each other or not. Secondly, it tells us if they are related, what is the nature of relationship, that is positive or negative. And finally, it tells us the strength of relationship between them. That means how strongly these two variables are associated. Now, if you want to get some other answer beyond these three things, correlation does not have power to give you answer anything beyond these three, right? Now, once I say anything beyond these three, it means I may be interested to know who is dependent on whom. That means whether these two variables can be classified into dependent or independent category, right? Secondly, can I predict a variable, right? So in case of correlation, it is useful only when you want to know the nature of relationship and the strength of relationship between two variables. But once you want to graduate yourself with little more investigation, like dependent and independent variables, and the prediction of dependent variable, if you know independent variables value, then correlation coefficient could not help you. In this regard, a technique comes out which is called regression analysis, right? So regression analysis is also a relationship establishment analysis, but more than establishing a relationship, it helps us with a mathematical equation between two variables, so that if we know the value of independent variable, we can predict our dependent variable, right? Now, regression can be of many types. It can be simple regression. It can be multiple regression. Simple regression, when you have only two variables, like in our case, x and y. If we try to establish a relationship between these two, it is simple regression. But once the number of variables are more, then the regression performed between more than two variables will be known as multiple variables, right? Similarly, regression can be of linear regression. Regression can be of non-linear regression. For our case, we are discussing linear regression. Now, what is linear regression? When the relationship between two variables, if drawn diagrammatically, gives a line, right? Gives a straight line, then the regression between them is called linear regression. These are the formulae, right? Now, if you have two variables x and y, there are two possibilities. Either x is dependent and y is independent, or y is dependent and x is dependent. So, for two situations, you have two equations. The first equation says if y is dependent and x is independent, then the mathematical relationship can be established by this formula, right? Here, the formula says y minus y bar is the mean of y, equals to r. R means Carl Pearson coefficient, correlation coefficient between x and y. Sigma y is the standard deviation of y, by sigma x is the standard deviation of x into x minus x bar, right? If y is independent and x is dependent, then we need to draw x minus x bar equals to r sigma x by sigma y minus y bar, right? Where this is the formula for r, Carl Pearson correlation coefficient formula, right? So let us try our hands on this problem. We have been given a problem. It states perform regression analysis on the following data, right? Purposefully, I have not taken any known variable. Names of the variable are x and y, so we don't know which one is dependent, which one is independent. So uh, we will take once y dependent and x independent. So we'll try to find it out, regression line y on x. Next, we'll pick up y as independent, x as dependent, and we'll try to get the line, regression line y x on y. I'm sorry, this should be x on y. Fine. So let us first try to get the x bar. I have got the sum of x, I've got the sum of y as well. So our x bar equals to 240, that means summation of x, divided by 1, 2, 3, 4, 5, 6. So I have 6. Sorry, this is 6. Right? So x bar is 40. Coming to y bar, the total of y is 360. So 360, and we have 6 observations. So it is 60. Right? Next, we know the basic Carl Pearson formula. We require x minus x bar. So we are calculating x minus x bar. Right? So what is x minus x bar? Here is our x minus, here is our x bar, which is 40. Fine. So here it is thus 44 minus 40. Next 45 minus 40. Next is 43 minus 40. Next 34 minus 40. Last is 44 minus 40. Right? Next, we need to get square of this. Right? So square of this, x minus x bar was minus 10. So this minus 10 into minus 10. Likewise, it was 4. So into 4 for all the values. Right? Now let us get our y minus y bar. So y minus y bar, this is our y, minus y bar is 60. So it is 60. Next, this is our y, minus y bar is 60. Next, this is our y, minus y bar is 60. Next, y minus y bar. Next, y minus y bar. finally y minus y bar. Right, so this is our y bar. Next, we'll calculate y minus y bar whole square. So it is y minus y bar whole square. This into this, right? And likewise, it is for everything. Now, one last thing we need to calculate, which is x minus x bar into y minus y bar. Now to get this, this is our x minus x bar into this is our y minus y bar, right? And the similar thing we need to do for all the values. Now we need to get summation of this. We need to get summation of this as well and summation of this as well, right? So see, we need to calculate R. Now to calculate R, we need to calculate covariance of xy and sigma x, sigma y. So let me start with covariance of xy. So see, covariance of xy is summation of x minus x bar into y minus y bar. So this is the summation of this. So it is 32 divided by n, right? So n is 6. That means covariance of xy equals to 32 by 6, which is 5.6, 5.3. Next, we need to calculate sigma x. See, sigma x equals to square root sigma x minus x bar whole square. This is our x minus x bar whole square. So it is 202 divided by, this is our n, so 6. So square root of 202 divided by 6. That means 33.66, right? Equals to. So 33.66 square root is 5.80. Now, sigma y. So sigma y equals to square root of sigma y minus y bar whole square. This is y minus y bar whole square, and this is the summation. So 70 divided by n, which is 6. That means square root of 70 by 6 equals to 11.66. So 11.66 square root is 3.41, right? So almost we have everything except R. Now R equals to covariance of xy. So covariance of xy is 5.33 divided by sigma x. Sigma x is 5.8 into sigma y, which is 3.41. Right, so it is 5.33 divided by 5.8 into 3.41. It is 19.78. So 5.33 divided by 19.78 equals to 0.269, right? So this will be equals to 0.27. Now, see, we said we want to get an equation in which y is dependent and x is independent, right? So that is why regression line y on x we need to calculate. So it is regression. I'll simply write y on x. Fine. So formula says it is y minus y bar. We don't know the value of y, so it is y only, minus y bar is 60, right? Equals to r. R is 0.27. So 0.27 into sigma x by sigma y by sigma x. See, our sigma y is 3.41 divided by sigma x is 5.33 into x minus x bar is 40, right? So, should I take this up little? So it is y minus 60 equals to, see, if we divide 3.41 by 5.33, it is 0.63. So 0.27 into 0.64. Actually, it is 0.639. So 0.64 into x minus 40, right? So if we calculate further, it is y minus 60 equals to 0.27 into 0.64 equals to 0.1728 in bracket x minus 40. So I'll take y in this side of equation and send 60 to that side. So it will become, now if we take two decimal, that is 0.17, and if we multiply inside the bracket, we'll get 0.17 0.17x, right? Minus, now 40 into 0.17, it is 6.8, 6.8, and 60 will come here, so it is plus 60, right? That means we get y equals to 0.17x. Now 60 minus 6.8 is plus 53 point, right? So we have got a mathematical equation between x and y. Now say we have decided y is dependent and x is independent, right? So get any value of x, put in this equation, and it will give you a value of y accordingly, correct? So this is the utility of regression analysis. Now let us try to project y on x. I'll just take these things a bit down. Much. Fine. Now we are calculating x on y. Fine. If it is x on y, then we need to write this formula. So x minus 40 equals to R is same, that is 0.27, but now the fraction is changed. See, here it was sigma y by sigma x, now it is sigma x by sigma y. So it is 5.8. I'll just make a little change in this thing. This is not 5.33, this is 5.8. So this will change accordingly. 3.41 divided by 5.8. It is 0.0.559. So now 0.27 into 0.59 equals to the 0.15. It is 0.16 actually. So now this will become 6 and this will become 6.4. So this will become 6. Right? I'm sorry. Instead of sigma y, I put the value of r. Correct? Now, here let us come back on x on y. So x minus x bar equals to r. Now sigma x. So sigma x is 5.8 divided by sigma y, which is 3.41 divided by right into y minus 60. Fine. So it is x minus 40 equals to 0.27 into, see, 5.8 divided by 3.41. So it is 1.7 in bracket y minus 60. So x minus 40 equals to, now 0.27 into 1.7 is 0.45 in bracket y minus 60, right? So oh, so this will be that we keep x here, x equals to 0.45y minus 4.5 into 60. It is 270 and 40 will come this side, so it will become plus 40, right? So the final equation is x equals to 0.45y minus 30, right? So I'll write the final equations here. Y on x. This is our y on x. Next is x on y. And this is our x on y. Fine. So this is our simple regression equation, right? Now, whoever is the dependent variable, you can choose your equation accordingly. If y is dependent, choose this equation. If x is dependent, choose this equation. So this is the utility of regression, that it not only tells about the nature and strength of the relationship, but it also gives you a mathematical formula so that you can predict your dependent variable, right? Hope you have understood the concept. For any further query, you can contact me on arg.srkr86@gmail.com. Thank you.